So for this lesson, we're going to start looking at differences of squares in a quadratic equation. And the first thing that I want to do is I always want to rewrite in the form of, so we're going to write in the form a squared minus b squared. And so right now I have the 16h squared, and that is actually going to be 4h squared. And the reason how I got 4h squared was because I needed to think of what number squared equals 16. And so I'm basically just factoring out that squared portion of it. And I'm going to subtract a 3a, and we're going to square that. And then I'm going to find my differences of those squares. So basically, because both of them are squared, I can write that this is 4h minus 3a and times 4h minus 3a. And so I still have multiplied two 4h's and two negative 3a's. And since I know that I don't have that middle term like I usually do in a polynomial, then I realize that one of these terms has to be positive and one has to be negative because they're going to cancel each other out. So I'm just going to make one of them positive. And we could even test this to make sure that we get our 16h squared minus 9a squared. So 4h times a 4h gives me a 16h squared. Then I'm going to get minus 12 HA plus 12HA minus a 9A squared. And see, these middle terms would cancel out, so that's why I wanted to make one positive and one negative. So let's take a look at our other example. I'm going to rewrite in the form of a squared minus b squared. So I'm going to get the 121 gives me 11 squared minus 2b squared, because 2 times 2 is 4. And then I'm actually going to get an 11 minus 2b times 11 minus or plus 2b, because I had that middle term cancel out. For our last example, we can see that we could factor out a 3g from each of those terms. So I'm actually going to get that I have 3g times 9g squared minus 1. And then I could rewrite this to say 3g times a 3g squared minus 1 squared. And that's going to give me 3g times 3g minus 1 times a 3g plus 1 as my final answer. So I just factored out what they had in common so that I could find my a squared minus b squared. Go ahead and pause the video, and I want you to try these two on your own. So for our first example, I'm going to write as our differences of squares. So I'm going to have a 9 squared minus c squared. And then this is going to be rewritten as 9 minus c times 9 plus c. Make sure that you have one that's negative and one that's positive c so that our middle terms cancel out. For our next example, we're going to factor out an x. So I'm left with x, 9x squared minus 4. And when I rewrite this to have a squared minus b squared, I'm going to have that x times 3x squared minus 2 squared. So then I can rewrite to say x times 3x minus 2 times 3x plus 2 as my final answer. For our next example, we have b to the fourth minus 16. And since each of those are to the fourth, I still want to get to that a squared minus b squared. So I'm going to actually still write the same thing. So I'm going to have b squared, and that's all going to be squared. And I know that I wrote that because I want b to have an exponent of 4. So b squared to the second power is going to give me b to the fourth. And then I'm going to subtract 4 squared because 16 is 4 times 4. And then to rewrite this, I'm going to get that b squared minus 4 times b squared plus 4. And I want that middle term to cancel out, and so that's where I get my positive 4. Just as the same for our next example, I have 625 is 25 squared minus x squared to the second power. I'm going to rewrite that to say 25 minus x squared times 25 plus x squared. And I still have that negative and positive to get my middle term to cancel out. I want you to go ahead and pause the video and try these two on your own. So we have y to the fourth minus 1. So to rewrite that, I'm going to get y squared to the second power minus 1 squared. And that's going to equal y squared minus 1 times y squared plus 1 as my final answer. For our next example, I'm going to write 9 squared minus x squared to the second power. And that's going to equal 9 minus x squared times 9 plus x squared is my final answer. For this example, we have 5x minus 45x. And following our same path of being able to factor something out, I want to factor out the greatest common factor. Well, our greatest common factor with this example is going to be a 5x. So when I factor out a 5x, I'm going to get 5x times x to the fourth minus 9. And this x to the fourth minus 9 is exactly what we just practiced on in our last few examples. So I could rewrite that to say that I have 5x times x squared to the second power minus 3 squared. So now what's inside of our brackets looks like just what we did in our last example. So I'm just going to simplify that. So I'm going to have 5x times x squared minus 3 times x squared plus 3. For this example, we're still going to factor out our greatest common factor from each term, which is going to be 7. So when I factor out 7, I'm left with 7 times x cubed plus 3x minus x minus 3. And I see that I could use our grouping method. And actually, this 3x should be 3x squared. I'm going to use the grouping method right here so that I can pull out another term so that I have my differences of squares. And those both actually have an x with each other. So when I have this, I'm going to factor out that x squared. So I have 7 And then I have x squared times an x plus 3. So all I did was I used my grouping method to say, okay, here's my two groups. And then I'm going to subtract, and on this group, I'm going to factor out a 1, or actually a negative 1. So when I factor out that negative 1, I'm going to have negative 1 parentheses x plus 3. And I'm going to close my bracket. And remember that when I use my grouping method, the things that are in the parentheses, that polynomial, I want to look the same. So I have an x plus 3 times an x plus 3. So this can be rewritten as 7 times x squared minus 1 times x plus 3. And I see that that x squared minus 1 is a differences of squares again. And so just on the side, x squared minus 1 gives me that I have x squared minus 1 squared. So I'm going to have x minus 1 times x plus 1. So I could rewrite my polynomial as 7 times x minus 1 times x plus 1 times x plus 3 as my final answer.